Hello students, how are you? I hope you are doing well. Today I have come with around 5 to 6 questions based on modern physics which were asked in the first shift of 29 January 2023 JEE mains. So let us discuss them one by one. So here comes the first question. As you can see, the threshold wavelength for photoelectric emission from a material is this much. Photoelectrons will be emitted when this material is illuminated with monochromatic radiation. Now try to understand students the from the threshold wavelength, okay, we can get an idea of the nature of radiation which will be able to show photoelectric effect. Now this color corresponds to yellow color. You should remember it is somewhere in the yellowish green range, okay, 55 degree angstrom. Now we okay, violet has a wavelength roughly around 4000 degree angstrom, and red has a wavelength roughly around 8000 degree angstrom. So this lies in between, somewhere in the bluish green range. So this is the threshold wavelength. So all the radiation with energy more than this energy will be able to show photoelectric effect. So if energy is more means wavelength must be less. So all the wavelengths which are lesser than or equal to this will be able to show the photoelectric effect. Now coming to options, two options are for infrared and two options are for ultraviolet. Now you see students that beyond violet you have ultraviolet, UV, and within red you have infrared. So certainly infrared radiation will not be able to show photoelectric effect. So the correct option is ultraviolet lamps, regardless of the intensity, because intensity is just a governing factor for what, for the number of photoelectrons which are ejected by the photoelectric surface. That's all. Number of electrons. It has nothing to do with whether it will eject the electrons or not. So correct statements are C and D. So fourth option is the correct option. Moving on to the next question. If a radioactive element having half-life of 30 minutes is undergoing beta decay, the fraction of radioactive element which remains undecayed after 90 minutes. Now first find out the number of half-lives. Number of half-lives. So total in 90 minutes, the number of half-lives are 3, because each half-life is of 30 minutes. So 3 half-lives are there. Now the fraction of radioactive element which remains undecayed is, see, at the end of first half-life it will be this much. The second, at the end of next half-life again it will be this much, and at the end of next half-life it will be this much. So altogether 1 by 8th of the initial uh, what you call radioactive substance will remain undecayed. So correct option is 1 by 8. Okay. Then moving on to the next question, a radioactive element X emits two alpha particles, one electron and two positrons. The product nucleus is represented by this. Now students, you have to understand that this electron is because of a negative beta decay, and these positrons are because of a positive beta decay. This will affect only the atomic number. Beta decay affects only the atomic number, not the mass number, whereas alpha particles will affect both the atomic number as well as the mass number. So coming to this, the atomic number of parent nucleus is 92. Now at the end of 2 alpha particles decay, the atomic number will reduce by 2 into 2, because corresponding to each alpha particle, remember alpha particle is nothing but helium nucleus. So corresponding to the ejection of each alpha particle, the atomic number will reduce by 2. So two alpha particles are there, so 2 into 2. Then corresponding to one beta decay, the atomic number will increase by 1, and corresponding to positive beta decay, it will decrease by 1. So two positive decays are there. So this will be 92 minus 4 minus 1, that is 87. So 87 is the answer. Then moving on to the next question, if the height of transmitting and receiving antennas are 80 meter each, the maximum line of sight distance will be. So students, I am going to derive the formula, but you have to memorize this, okay, so that you save time in the exam hall. So this is the, let us say this is the earth, and this is the height of the transmitting tower or receiving tower, any one tower. I'll take it as H. So A, B is the tower. O is the center of earth. Radius I have taken as R, radius of earth. If you draw a tangent from here, as you can see, let the tangent touch the earth at point T. So let us join it. So certainly this will be a right angle triangle. Also, let us straightaway join A with D. So this is the distance D. For now, I take this distance as R. So from this right angled triangle, you can see, from the right angled triangle OTB. From this right angled triangle, I can write OV square is equal to OT square plus BT square. Is it? So what is OB? OB is R plus H. R plus H, and OT is again R, of course, and this is R square. Now you can further see, students, that this is another right angle triangle, triangle BTA, right angled at A. So applying Pythagoras theorem once again, in triangle BTA, R square can be written as H square plus D square. I'll open this bracket. So R square plus 2RH plus H square is equal to R square plus H square plus D square. So as you will see that R square gets cancelled as well as H square gets cancelled, and we are left with this 2RH. So D square is equal to 2RH. So D will be under root 2RH. This is the formula for the height of the antenna. It could be receiving or transmitting antenna. Now in this particular case, we have been given the heights of transmitting as well as receiving antennas, and we have to find the maximum line of sight distance. So let us see how we can solve this. So this is the earth. This is the earth. Then just draw two tangents here. So this one of them will be the transmitting antenna. The other will be the receiving antenna. Okay, so if this height is h1 and this height is h2, then as you know, this distance is d1 and this distance is d2. In fact, both the distances are same approximately. So the required maximum line of sight distance will be d1 plus d2, which just now we have derived this. You have twice r h1 plus under root twice RH2. So here in this case, both heights are same. So we can double any one of them. Okay. Radius of Earth is given as 6.4 into 10 power 6 and heights are 80 meters each. And options are in kilometers. So this is 6.4 into 10 power 6. So I have made it as, sorry, I have taken one 10 from here. So it will become 10 power 5. Height is 80 meters. Height is 80 meters. So this is a perfect square. As you can see, 2 into 8 is 16. 2 into 8 is 16. 64 will remain as it is. 10 power 5 and another 10 will make it 10 to the power 6. So this is a perfect square. Square root of 16 is 4. Square root of 64 is 16. Oh, sorry, 8. I'm sorry. Then for 10 power 6, it will be 10 power 3. Since we have substituted all the things in SI unit, we can expect the answer to be in SI unit. So this will be kilometers. So this will be 8 8s are 64 kilometers. So 64 kilometers is the correct answer. Fourth option is the correct answer. Moving on to the next question. Which of the following statements is not true in the case of light emitting diodes? Students, light emitting diodes are basically those diodes which emit light during the flow of majority charge carriers across the depletion layer. And as we know, if majority charge carriers have to flow, then it should be in the forward biased. So it it emits light only when it's forward biased. This is correct. It is a heavily doped p-n junction. Yes, it is. It has to be a heavily doped p-n junction. The energy of light emitted is equal to or slightly less than the energy gap, because only certain photons are fortunate enough to carry the entire energy, which is the energy difference between the two energy levels in which the electron is jumping. Okay, otherwise some certain energy is lost. So therefore, the energy of photons of the light emitted will always be slightly less normally than the energy released. So these all things are correct. This is wrong, student. Option 3 is wrong. It emits light only when it is reverse bias. If it is reverse bias, it will not emit any light theoretically. So that means we have to select the incorrect one. So option 3 is the incorrect one. That's all in this video, students. Thank you for watching. Thank you so much.